Hello student, here is the question that six identical cell each of EMF E and resistance R are joined in a series to form a closed circuit. Only one cell A is joined with the reverse polarity, then the terminal potential difference across the A. So here is the six identical cell, one resistance is R, identical cells are there, 1 E and R, 1 2 3, here is the cell 1 2 3 ER, that's a 4, 1 2 3 4, and that's a 5, 1 2 3 4 5 and 6. You are connected this in to form a closed circuit. So 6 is connected in reverse polarity, so you have to connect it in reverse polarity. So here is the cell 6 cell, that is called A is joined, one cell A is joined, here is the one, here is EMFE, and yeah, these are forming a closed path. So you can now, these are the 6 cell, so you can see that's a one cell, that's another second cell, this is the third cell, this is the fourth cell, here is the fifth cell, and last one this cell is. Okay, now this is the closed path, so you can apply the KVL here. So just move from the one point, so take this point and move from this point and flow clockwise current here. So current is this. Okay, so you can write that the current is flowing from higher potential to lower potential. So just write the letter sign, that's a minus I into R. Okay, now pass through that battery, there will be a decrease in potential. Okay, now the current will pass through this resistance, there will be drop of I into R, and will pass through that that battery, so that will be equal to plus E. Its potential will get increased. Now here the potential drop is again IR, so you can see minus IR. Okay, so instead of writing again and again, I am just writing how many resistance are there, 1 2 3 4 5 6. So it will be directly I am writing, it will be 6 into R. Okay, so here is I will write that's a minus after passing through this. Here I am direct writing this. So here is the, here is that's a minus 1 2 3 4 5 6. So minus 6 into R, that's a potential drop you will find after passing through this loop. Okay, so here is the 5 batteries connected in the same polarity, so that will be 1 2 3 4 5. So you will get that's 5 into E. Okay, so you will get the positive sign when you are moving there, so its potential difference will be 5 into E. So here this battery is in negative polarity, so you will write that's minus E. Okay, so that's equal to that's a 6 into I into R. Okay, so here potential difference you are writing, so I into R in this, 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 so you will get 6 into I into R and plus 5 E and minus E. So that total net potential drop, that will be equal to 0. So just you are applying the KVL, so from KVL I can write this equation directly. Okay, I am just writing the that's minus IR and that's minus IR, that's minus IR, that's minus IR, that's minus IR, that's minus IR. Okay, so it will become the minus potential drop. If you are taking the letter sign minus minus minus, it will become the minus 6 IR. Okay, so here is minus 6 into I into R, minus 6 into I into R. Okay, that's a potential drop. Now here is you are when you are moving the first terminal of the first battery is that's a positive, that's a negative, take the letter sign, you will get minus E, and rest of the batteries are in the positive sign, are coming out letter sign. Okay, so here is the positive sign, so you will get the 5E. Just solve it out. So that's a net potential drop you have in the circuit, so just solve it out, that will be equal to 6 IR is equal to 4E. Okay, so I is equal to you will get that current in the circuit will be equal to 4E upon 6R. Okay, so you will get that's equal to 2 by 3 E upon R. So this is the current which is flowing in the circuit, and you have to calculate the terminal voltage, terminal potential difference across the cell. So here is the cell which you have, here is this is the cell A. So you have to calculate the terminal potential across this cell. So let's say this potential is P and Q. So potential difference between P and Q you have to calculate. So current is flowing like that. So start with the point Q. Okay, that's a Q, and later move minus I into R, and then battery, that's a minus E, and that's a point is Q. So Vp minus Vq, terminal potential across this cell, that's equal to Vq minus Vp is equal to E plus IR. Okay, so just put the value here. You will get the value of IR from there. You can calculate that IR is equal to 2E by 3. Okay, so put the value IR here. So that's equal to 2E by 3, and you will get that's equal to 5E by 3. 5E by 3. So this is the answer. This is the potential difference between across the cell A. So it matches with your option number. Which your option number? No, it's not your answer. So 5 by E. Okay, it matches your option number 2. So option number 2 is the correct answer of this question. Okay, thank you.